Well, today we're going to be discussing Chapter 2, Lesson 3, Rate of Change and Slope. Now, this is something that you've talked about quite a bit before, so this should be a pretty easy lesson for you. These are our content standards today and our mathematical practice, so please pause for just a moment and read those as we move forward. Previously, you've graphed linear relations, and now we're going to find the rate of change, and we're going to determine the slope of a line. We've got just a little bit of new vocabulary, which probably isn't too new to you: rate of change and slope. Now, rate of change is a ratio that compares how much one quantity changes, on average, relative to the change in another quantity. Now, say if x is the independent variable and y is the dependent variable, then the rate of change is going to be the change in y over the change in x. And usually time, so we've got dates here, we place along our x-axis. So that is our independent variable. There's not much we can do about time, right? It just keeps on passing by whether or not we want it. So it's a change in y over the change in x. So our y is going to be change in admissions and, of course, change in time. We put our time across the x-axis, so time is x. So we have 60,291 students, and we'll subtract the 56,878. And our changes in x, 2006 minus 2004. We subtract them from each other. So the rate of change is 1,706.5. This means that the number of students applying for admission increased by 1,706.5 each year. So there's that half a person, huh? Wonder which half. So let's check your progress. So we're wanting to find the rate of change for the data in the table. Now, to help you out a little bit, our time is x, so that means our distance is y. So we need the change in y, 56 minus 8, over the change in x, 14 minus 2. Pause for a moment and calculate that, then come back and check your answer. So did you end up with 48 divided by 12, or that becomes out to 4 feet per minute? So that is our average rate of change. Okay, refer to the graph below, which shows data on the fastest growing restaurant chain in the United States during the time period on the graph. So it looks like we're looking from 2000 to 2006. Find the rate of change in the number of stores. Okay, so they start graphing at 2001 to 2006. Now, up to this point, we've used rates of change that are constant, but real-world situations, they involve rates of change that are not constant, and that's what we have in this situation. It's not a straight line anymore, is it? So we're going to look at the average rate of change over a specified period. We're going to use the same process, but this is not going to be a straight constant rate of change. It's going to be an average rate of change. So that's still the change in y over the change in x. So change in number of stores over time, 33 minus 6 over 2006 minus 2001. So 5.4. So between 2000 and 2006, the number of stores in the United States increased at an average rate of 5.4, and that's in thousands. So that's 5,400 stores per year. Wow. Okay. Time to check your progress. Again, we're using the same rate of change in y over the change in x. So pause for a moment and calculate, and then come back and check your answer. Okay, did you get 74 minus 61 over 2004 minus 2000? So we're going to have 13 divided by 4, because it's going to be 13 over 4, which is an increase of 3.25% per year. Good job. Another key concept, the slope of a line. So our two concepts we're learning about today, rate of change and now slope. Now the slope of a line is the ratio of the change in the y coordinates corresponding to the change in the x coordinates, which we've already done, change in y over change in x. Now the slope of the line is the same as is the rate of change. Calculate it the same way. So now we're going to find the slope of a line that passes through these 2 points. So if we call this point 1 and this point 2, so this is x1, y1, x2, y2, and that's what they've labeled here. Okay, so we'll have -2 minus 4 over 1 minus a -1, and simply do the math. -6 over 2 or -3. So our slope is -3. Time for you to check your progress. Find the slope of the line that passes through point 9, -3, and 2, 7. So pause the video for a moment, come back and check your answer. So 7 minus a -3 over 2 minus 9 gives you a -10 over 7. So the answer is B. Awesome. Okay, our last example. Now we're going to find the slope of the line from a graph. So what we have to do is choose 2 points. We're still going to use the slope formula. It looks like we're going to use point 1, -1, 0, and 1, 1. Okay. So see how simple that was? Still using the same old formula. So our answer is 1/2. Okay, time for you to check your progress. Find the slope of this line. Let's pause the video, determine your points, and find the slope. Okay, did you use point 3, 0 and -6, 2? So you end up with 2 minus 0 over -6 minus 3. So it's equal to -2/9. Good job, folks. Okay, you're ready to begin the exercises.